Okay, welcome back to the next video. This is Math 126, the video for section 4.5 and 10.1. As of now, there's no comments in the discussion section, so I just grabbed a random sample and those are the ones I'll do. If you have other comments, questions, put them in the discussion board and we can talk about those. Let's start in 4.5. Let's look at number 1. Oh, number 1 says solve for x. And we have this equation, 2 to the x equals 32. Okay? So if I want to solve for x, I can rewrite both of these in the same base. And I can do that because 32 is 2 to the 5th. And so I have 2 to one power is equal to 2 to another power, and that's my solution then, is that power must be the same. There's no other number here that's going to equal 2 to the 5th, so I then have x must be equal to 5. And I'm done. That's my answer. Let's take a look at number 3. Okay. 3 is 4 raised to the x equals 2. Same question, solve for x. And so we again want to do the same thing. We want to rewrite both sides as the same base raised to some power. Obviously the right hand side is 2 to the 1, but I can't write 2 to the 1 as 4 to some power, but I can write 4 as 2 to a power, right? And so 4, because that's 2 squared, I can in place of 4 write 2 squared, so I have 2 squared to the x is equal to 2. But if I have something raised to a power raised to something else, then those powers multiply, so this is 2 raised to the 2x is equal to 2. That is 2 to the 1. And therefore, if I have 2 to one power is equal to 2 to another power, those powers must be the same. And so I get 2x must equal 1. And then, of course, that means x equals 1/2. Alright, so those ones I think are fairly easy, not too bad. You might see ones, I just kind of randomly grabbed a couple of them. So I didn't see one like this, but I'm sure they're in there. You might see something like, let's say 9 to the x equals 27. For example, just a random question here. And I can rewrite, I can't write 27 as a power of 9, right? Because 27 is 9 times 3, that's not a power of 9. But they're both powers of 3, right? So I can write 9 as 3 squared to the x. 27 is 3 to the 3rd. And now I have these in bases of 3 as soon as I just simplify this. So I get 3 raised to the 2x is equal to 3 raised to the 3. And therefore 2x must be equal to 3. And x must be 3/2. Right? So be aware of those, that type of scenario. But those can be solved as long as both sides can be written as the same base to some power. So let's move on. Let's take a look at number 5. What happens when we get this e thrown in there? E to the 4x equals 19, for example. I don't know what 19 is as a power of e, so I have to rewrite this as a logarithm. And since e is the base of my exponential, it's going to be the base of my logarithm, so I get a natural log. And this turns into the natural log of 19 equals 4x. The natural log of 19 is just some number. We'll have to throw that into a calculator to figure it out. But I can solve all the way for x by simply dividing by 4. And therefore I get x isolated and x is the natural log of 19 divided by 4. Now make sure that you don't take, let me just write this over here. I'm going to rewrite it the other way here, x on the left. This is the natural log of 19, and then that number is divided by 4. Don't put it into your calculator so that you're taking the natural log of 19 over 4. That's different. Those two are not the same. We don't want that. We want the natural log of 19, the result of that divided by 4. Right? So I didn't plug that into a calculator. I should have. Let me just throw it in here. So I get 0.7361097, something like that. Goes on and on and on forever. And the instructions ask us to round it to 4 decimal places. So 1, 2, 3, 4, that's the 1. The next one is a 0, so my answer would be 0.7361. That's what we're looking for. Try it. Take the natural log of 19/4, and you're going to get not that number, right? So make sure that you put it in your calculator right, and you understand you're dividing the natural log of 19 by 4, not 19 by 4, and then taking the natural log of it. All right, let's look at number 8. Which says e to the 2x minus 4e to the x plus 3 equals 0. Okay. Now we're going to use another u sub here. We've seen these before. This looks like a quadratic, and it is. E to the x I'm going to let equal u. Because if I square u, that's e to the x all squared, that's e to the 2x. Right? So I can replace e to the 2x with u squared, I can replace e to the x with u, and this becomes a nice quadratic. This becomes u squared minus 4u plus 3 equals 0. I can factor this. This gives me u minus 3 times u minus 1. And therefore I can break this down to either u minus 3 is equal to 0, or u minus 1 equals 0. Can you see that far over? Let's see, maybe just a teeny tiny movement here. Oh. There we go. Maybe that's helpful. But again, I don't really care about u. I want to know about the x. And so u becomes e to the x again. So this becomes e to the x minus 3 equals 0. I can add my 3 over, so this becomes e to the x equals 3. And then I can rewrite this as a log. This becomes the natural log, because the base is e, of 3 is equal to x. Same story over on the other one. U is e to the x, so this becomes e to the x minus 1 equals 0. Add the 1 over, I get e to the x equals 1. I can rewrite this as the natural log of 1 equals x. Right? The natural log of 1 I know is 0, so I get a 0 out of this. The natural log of 3, I don't know off the top of my head, so let me throw it in here. 1.0986 ish, something like that. And it wants us to round this to also 4 decimals. And so that would be it. And then let's take another look at, let's look at number 12. Okay, 12 says the log base 3 of x squared minus 2x minus 26 equals 2. Okay. So I need to break this out of the logarithm, so I'm going to rewrite it as an exponential with 3 as my base raised to the 2 equals this x squared minus 2x minus 26. 3 squared is 9. I should know that. And then I have a quadratic, so I'm going to grab my 9 and pull it to the other side, so minus 9 from both sides. And this is going to give me 0 equals x squared minus 2x minus 35. Okay. So I have this. I can factor the right-hand side. This becomes still 0 equals. This factors to x minus 7 and x plus 5. Okay. And therefore I have x minus 7 is equal to 0, or x plus 5 equals 0. So that is to say I have x equals 7 or x equals negative 5. Now there is one thing that you want to do is to make sure that both of these answers are valid, because if I plug 7 into the polynomial inside the log, it needs to be positive because I can't take the log of a negative number, right? And so x squared minus 2x minus 26 has to be positive when x is 7, and it has to be positive when x is negative 5, otherwise I need to eliminate the answers where it isn't positive. So I'll check that. We're just plugging in 7 into the polynomial, so we get 7 squared, which is 49. Minus 2 times 7 is minus 14, and then minus 26. Right? But this is 9. It's positive, so it's good. Right? If I plug in x equals negative 5, I should get the same thing. It should be positive. It should end up being 9 as well. So let's do it. X squared when x is negative 5 is positive 25. Minus 2x when x is negative 5 is minus 2 times negative 5. That's plus 10. And then minus 26. That's also 9 positive. So it's good to go. Both answers are valid. And there we go with both my answers. Alright, hopefully that gets you going for 4.5. Again, I didn't see any comments on the discussion board, so hopefully you guys are still in there. Get in there, do your homework. You know, don't fall behind at this point. We're almost there. So ask questions, throw them into the discussions. Right? We'll get you any answers that you need. So don't disappear on me. Let's take a look at 10.1. 10.1 is systems of equations. And it talks about a couple of different methods. It talks about, I think it talks about graphing. Graphing is a terrible method to solve a system, especially if you're doing it on a whiteboard. Every time I try to draw out a system, I never get the answer because I can't draw a straight line to save my life. So they go on and talk about substitution. And let's take a look at number 1 that says to use substitution. Substitution is a pretty good one. It doesn't work, it works every time. It may not just be pleasant every time. So let's take a look at this guy. My camera's wigging out on the focus. I don't know why. Maybe it's because it doesn't know what it's focusing on. There we go. Knock it off, camera. This is the system x minus y equals 1 and 4x plus 3y equals 11. Now, substitution is kind of designed when it's easy to solve for one of these variables. This x is super easy to figure out. In fact, all I'd have to do is add a y to the other side. So if I add y to both sides, that just leaves me with x on the left, and then y plus 1 on the right. Right? I think we can all see that. But that tells me that x has to be equivalent to y plus 1, which means I can take this y plus 1 and say, since it's equivalent, that I can replace the x in the other equation with y plus 1. So I will. I'll have 4, and instead of multiplied by x, I have multiplied by y plus 1. And then the rest of the equation, plus 3y equals 11. And then I simplify, and I only have one variable here, I just have y, so it should be easy to simplify down to y equals some specific value. Start here by distributing, that gives me 4y plus 4, plus the other 3y is equal to 11. 4y plus 3y, that's 7y. Right. Subtract my 4 to the other side, that'll give me 7y alone on the left. 11 minus 4, that's 7. And so if we divide by 7, we can see that y equals 1. And I have half my answer, I have the y value. Now all I have to do is figure out my x value, and I can do that by resubstituting this y equals 1. I can replace the y for 1 in the original equation up here. Or one of these original equations, it doesn't matter. But this is already nicely solved for x, so I'll do it there. This gives me x equals y, which is 1, plus 1, and therefore x is equal to 2. So my solution here is the ordered pair x equals 2, y equals 1. And that's that. And that's how they want you to put it into the homework. Parentheses as an ordered pair, parentheses 2 comma 1, no spaces, and that should do it for us. Now, like I said, substitution is kind of designed for when it's easy to pick off one of those variables and solve for it. And this last one, all I had to do was subtract my y over, and I had an x isolated. If it's not easy to do that, then the addition or elimination method is typically better. So let's look at number, let's say 3. It says use the addition or elimination. It's the same method, just called 2 different things. But we're going to use this method to solve this equation, this system of equations. I have 4x minus 3y equals 23. And then I have 8x plus 4y equals negative 4. And that's not to say I couldn't use substitution here, right? I could just figure out which one of these I want to solve for. And if it were me, most likely it would be this y in the second equation, because I move the 8x over, divide everything by 4, and I avoid fractions. But if I try to solve for any other variable, I'm stuck with fractions, right? So if you want to do this with substitution, just for the fun of it, I would probably solve for that y first. But it says to do it by elimination, so we're going to do it by elimination. What I want to do is multiply, where's my red? I want to multiply these equations so that one of the variables, either the x's or the y's, will cancel out when I add the 2 equations together. Now it's probably super easy to turn this 4x into a negative 8x so that I can combine it with the 8x, and that'll get me what I want. So I'll do that. Multiply everything in this equation by negative 2. And I'm going to leave this bottom equation alone. I'm not going to change it. That gives me this new equivalent system of negative 8x. The negative 2 distributes to everything, so plus 6y. And negative 2 times 23, negative 46. Bottom didn't change, so I have 8x. plus 4y equals negative 4. And I'm going to combine those. Like I would just add, the left-hand side of this equation to the left hand and the right-hand side to that right hand. And the negative 8x and the positive 8x will cancel out. Gone. That leaves me with 10y equals negative 50. And just like that, I have y. Divide by 10, and I have y is negative 5. In my opinion, this is typically fewer steps. The initial setup you have to be careful with, but it's quicker, I think, to get to that first variable, that first value. To figure out the other one, I'm just going to take y equals negative 5 and plug it into one of my original equations. It doesn't matter which one. I should get the same answer no matter what I do. I'll take the top one because they're smaller numbers. And so I have 4x minus 3 times, not y anymore, but negative 5 equals 23. I have one variable, so I should be able to solve this for that variable. So let's do, this turns out to be 4x plus 15 is equal to 23. Minus 15 from both sides gives me 4x is 8. Divide each side by 4. And I have it. So my ordered pair is 2, negative 5. Okay, let's look at one more. Let's look at number 9. Number 9 says use any, I think it says use any method. But we've got negative 2x plus y equals 1 and 4x minus 2y equals negative 2. Now, I'm a fan of the elimination method, so I'm going to multiply the top by 2 so that my negative 2x becomes a negative 4x and will cancel with my 4x below it. So negative 2 up top, the bottom doesn't get changed, or you can think of it as multiplying by 1, whatever you want to think of it as. This gives me the new equivalent system of negative 2 times, oh I don't want negative, sorry, just a 2 there, because I want 2 times negative 2 to give me negative 4x. 2 times 1y is plus 2y, and 2 times 1 is 2. The bottom one's being multiplied by 1, so it doesn't change, so that's 4x minus 2y equals negative 2. And when I combine these, negative 4x, positive 4x, they cancel out.